Hey everyone, this is Chiranjeevi, and in today's video we are going to talk about the visitor design pattern. So let's get started. We have a visitor here today, so let's entertain him. So by definition, a visitor design pattern is a behavioral design pattern that lets you define a new operation without changing the classes of the objects on which it operates. Now, the definition is quite simple, but it can be quite difficult to understand the actual intent behind the visitor design pattern. So what I have done here is I have taken a very good image which shows you what a visitor means. So we all are familiar what's a visitor. So you have a home and you get some visitors. So the visitors come to your home and they stay for some time and they go away. Right? That's what visitors do. They come to your house, they stay for some time, and they go away. And that's a very simple analogy that this design pattern is trying to make. Okay, so now what we are going to see here, we are going to create a need for this visitor design pattern, and then see the UML diagram, how this visitor design pattern tries to solve this problem, and then continue with it. Okay, so let's get started with the example. So I have created this very small example which I will then modify to use the visitor design pattern to solve this example. So let me go through this example once so you understand what I'm trying to do here. So what I have created here is a chess component, which is an abstract class, and it has a component name. And it's a very simple abstract class with just one parameter and a one getter method. Okay, so now these two components, which is board block and piece, both are extending this chess component, and they are adding their own members like color, and board block also has a piece. So the use case which we are trying to solve is, let's that we want to visit all these chess component pieces on a chessboard one by one, and maybe print a console representation or a graphical representation for this. So the very basic idea which comes to our mind to solve this kind of problem is just let's just add a visit method, which is an abstract method in the base class, and let's just use the child of this parent class, override that method, and we will just call that polymorphically. Now, this can be a very elegant solution as well as a very bad solution. So as long as the visit functionality is tied to a single thing, it is fine, but the point or the instance at which the visit functionality tries to change, what you're trying to do here, you are changing the class behavior. Your classes are not cohesive anymore, right? So let's say we tightly couple this visit method to the console implementation of this abstract class, and we are just printing some values for this board block for now. But let's say in future we want to also have a graphical user interface for this chess component, and this visit method is going to be a problem here. The way you will try to solve this problem is you will have some if checks here, and you will also have maybe a boolean variable. So is console like something like that, or maybe if there are more than two flavors for this visit method, this visit method is going to be complicated, and that's what it is trying to snatch away from you. So you added this visit method. The first place was to use the benefit of polymorphism, but now you are seeing that this visit method is going to be a bottleneck for your code. So this is the exact use case this visitor pattern is trying to solve. So if you imagine it in another way, let's say this board block is a house, and just a visitor wants to come and paint the house, and that visitor can come and paint the house in any color, but we are not required to make the visitor stay in the house. We are not required to make him stay because he does not belong in the house. The only job this visitor has to come to the house, to paint the house, or do whatever job he wants to do with the house, to maybe talk with you, chat with you, and once he's done, he has to go away. but making the visitor stay in the house is going to be a problem, and that's what we are seeing here. This is the use case visitor pattern is trying to solve. You call a visitor to your house and you get the job done and the visitor goes away, and that's what visitors are for, all right? So let's look at the UML diagram and see how we are trying to solve this problem using a visitor pattern UML diagram. So yeah, this is the UML diagram which visitor pattern suggests. So visitor pattern has a visitor interface which has a lot of visit methods for each of the concrete component in your class hierarchy. So this component A could be a chess piece and this component B could be a word block. Depends on what your class hierarchy is. And this component here is your base class of your component hierarchy from which all your components are deriving. So in our case, this component base class is the chess component itself. Now, for each visitor interface, you will have a concrete visitor implementation which will provide the uh, implementation for each of the visiting for every component in your component class hierarchy. And finally, this client will have to call this concrete visitor. Basically, what this client will do is it will inject the concrete visitor in the component accept method. Yeah. So the component also now has an accept method which accepts a visitor. So you are welcoming a visitor to your house. You can imagine it like that. So you accept a visitor and then you ask the visitor to do whatever he wants to do with that piece or component. So whatever you do is you accept the visitor to your house or your class, and then you ask the visitor to do his job. So that's what the visitor pattern is. So let's look at the concrete steps we have to do in order to implement the visitor pattern from scratch. So now what I'm gonna do is I will extend my exercise or small example to actually follow with the visitor design pattern so it's easier for you to understand. So the first step says to create a visitor interface which has all the methods for the concrete classes you want to visit. So let's go ahead to our coding example and just create a visitor interface. So as you can see here, I have already a visitor interface over here. Now we have to add all the methods for the concrete classes you want to build. So we can see now we have two concrete classes. The first one is the board block and the second one is the piece. So now let's go to our visitor interface and let's add two methods for the concrete component hierarchy. So let's go ahead and add void visit piece and void visit block. Now what this visit piece will take an argument is a piece object, and similarly this block object will also take a board block object. Now this visitor can take a board block object and actually process this board block and return the result. So now let's go to our console visitor and actually implement this visitor interface. So while implementing, we will be adding definitions for these two methods. So let's quickly go to our previous example and copy this visit method implementation from here. So we have provided implementation for visit block and just change this .get component name to b.get component because b is the reference we are trying to use here. So let's replace all this by b. And let's go to the piece class and copy the implementation for visit from the piece class and paste it in the console visitor. Okay, so let's copy this, go to console visitor and replace. Here also we need to replace this by p because we are using p as a reference. So let's do that. And now we have a visitor in setup. So we have a console visitor which is going to print the values for this object in the console. Similarly, you can have a GUI visitor which can actually draw to the screen. So you will have draw piece and draw block. So you can define your interface like that. Since I have defined my interface like this, visit base and visit block. I am implementing those methods. So you are free to choose your own names. Now let's go to the abstract class, which is the chess component. So let's come to the steps now. So the first step is create a visitor interface which has all the methods for the concrete class you want to visit. So we have created this interface and provided one mini concrete implementation of this interface. So looks like we have also done this step 2. So we have provided a concrete implementation for this visitor interface. So the concrete implementation for this visitor interface is our console visitor, and this is the concrete implementation. So now let's go to step 3. The step 3 is to create an abstract method which accepts a visitor and implement it in subclasses which delegates call to appropriate visitor methods. So now let's go here. Let's go to the base class and create an abstract method here. So we'll say abstract void accept, and what this is going to do is this will accept the visitor which we just created. Now since this is an abstract method, we will have to provide implementation for this abstract method in the subclasses. So let's go ahead and quickly do that. Now since this is a board block, we can say visitor.visit block and pass the reference for this current block. Similarly, for a piece, we are going to implement the same abstract method, and let's call visitor v.visit piece and pass this reference here. So now we are done with step 3. We have to use this accept method to visit your classes. So let's quickly go to the main method and create some chess components over here. So the first component I am going to create here is a piece. Let's name it rook, and we create a new piece with a name rook. I think I have also added a color attribute to it, so let's add a black color rook to our hierarchy. Now the second chess component which I am going to create is a board block, and we'll call it a block. We can say new board block, and we can say it's a black block. And what are the other things? Let's take a look at it. So I want a name, I want a color, and I want a piece. So let's go ahead in the main method. Let's give it a name block. Let's give it a color white, and let's also give it a piece rook. So now this block has a white color and a rook piece. So now what we are going to do is we are going to print a console representation for this block by visiting this block and the piece which sits on this block. So for that, what we are going to use is we are going to use the newly created accept method and pass a visitor to it. But wait a second, we don't have a visitor yet. So that is what we are going to do next. So let's create a visitor. V is new console visitor. So now we have a visitor reference which can actually print to console taking the pieces. So just pass this v in the accept method, and now what this visitor will do is this visitor will go to the block, visit it, and then we can see the implementation for this visitor. So it goes to the block and it also traverses the piece which is put on that block, right? So let's go ahead and run this program, and then we'll compare this with the previous example. Okay, so this is the output for this program. It is visiting the block, and this board has a white color and a piece with name rook and color black. So our piece color is black, and I have forgot to print this color word here, so let's ignore that for now. And now we are going to compare this visitor pattern with the old polymorphic example. So now what we are doing here is we are creating a interface called visitor, and we have an implementation for this console visitor. Now the idea behind this is if we want to have more implementations for this visitor, we can simply go ahead and create more concrete implementations for this visitor, and all those concrete visitors can visit the same piece or block in a different way. Okay, but if you are trying to do that here you only have an abstract method called visit, and you have to override this abstract method in your piece or board block classes. But when you do that and you want to create more implementations for this visit method, your method is going to be tightly coupled with this visitation, which is not required in your class. So now we will go to the visitor interface again, and this is it what the visitor pattern means. It just basically takes your behavior and delegates it to a visitor interface, and the visitor interface takes care of handling your pieces. So this is how we implement the visitor design pattern, and these are the following steps which we will be using for this. I hope you have understood this UML diagram also, because we have mapped our example to this UML diagram as well. Because you can see we have an interface called visitor, we have a concrete visitor called console visitor, which is over here, and we have a component which is our chess component. It has an accept method, and our two component A and component B's are the piece and the board block. And in the client, what we are doing is we are calling that component.accept with a visitor instance. So this example clearly reflects that UML diagram exactly, and I made it in such a way so it's very easy for you to understand. So that's it everyone with the visitor design pattern. I hope you have understood this, and I'll see you in the next one. Thank you.